The first thing we will talk about is the scientific method and its importance. This method is the cornerstone of any science. You can't advance science without it. First step in the scientific method is to make an observation, meaning that you have to see, hear, or detect a phenomenon, or you could call it a problem, that you can't quite explain. Your observation would be between two or more variables in the problem. At this point, your observation is only true for the problem that you observe. Of course, if you didn't detect the problem you are trying to solve, then you could gather information from books, research papers, or your own experiences. It is important to find all the information related to the problem. The problem might already have been solved. If not, then all the information you gathered help you to be familiar with the laws that should, in principle, govern the problem. Next step is to form a hypothesis. Your hypothesis should be a relation between two or more variables in the problem, meaning that you are assuming that whatever relation you formed is true all the time for the problem. Your hypothesis should be falsifiable, meaning that there exists an experiment that could disprove your hypothesis. For example, you can't say the sky is blue because there are some mysterious particles that make it this way, and we can never detect those mysterious particles and they never interact with anything else. If you say that, then I could never be able to disprove your hypothesis because I can't directly detect your mysterious particles and I can't find traces of its interaction with other things that I can detect. Therefore, your hypothesis is not falsifiable. Next step is to conduct an experiment. In order to know whether or not your hypothesis is correct, you have to set up an experiment. Your experiment should not be identical to the problem, because your hypothesis is already true in that situation. Your experiment should be different and demonstrates the relation that is predicted by your hypothesis between the variables that are in your hypothesis. If there's a theory that explains and solves that problem, then your hypothesis is not accepted until it predicts different results from the theory in other situations. Meaning that the experiment must be set up in a way such that the hypothesis and the theory will predict different results for the same experiment. The final step, conclusion. If your hypothesis is correct, then the experiment will yield the results that are predicted by your own hypothesis. If your hypothesis is wrong, then the experiment would yield different results. Or, if there's a theory that already explains the phenomena, then the experiment would yield results that are predicted by the theory. Or the theory is also wrong or incomplete and the experiment would yield different results from both the predictions of your hypothesis and the theory. In that case, a new hypothesis is to be developed.